Hey everyone, Jen Person here, and I'm going to show you how to take a cloud storage trigger to the next level using the Admin SDK. Welcome to part 2 of writing a cloud storage trigger with cloud functions for Firebase. If you haven't watched part 1 yet, go ahead and check it out, and then come back when you're finished. I'll be adding on to the code for the function I created last time to address some problems that I left open. In the last video, I was building a photo app where users upload pictures, which then get displayed in a grid of thumbnail images. I showed you how to trigger an event from a cloud storage change, create a thumbnail using image magic, and write the thumbnail image back to storage. But what I want is a way to display the image in my app and share it with others. The easiest way to do that is through a public URL. Fortunately, I can add the Google Cloud Storage SDK to my Generate Thumbnail function to make the URL accessible to the app. I'm going to store the thumbnail's signed URL in the Firebase database so my app can find it. A signed URL allows access to the image, much like the download URL that you can generate using the Firebase Storage Client SDK. The signed URL provides access to a file in storage without requiring any form of authentication. I'm going to push a reference to my database with key value pairs containing the signed URL for the original image and the thumbnail using the Firebase Admin SDK. Then my app can read the URLs and display the images. Here we go. Before I can request a signed URL in my function using the Cloud Storage API, I need service account credentials. This is because it requires advanced privileges to authenticate my uploads. I do that from the Firebase console in my project by clicking the gear next to Overview, selecting my project settings, and choosing the Service Accounts tab. Under the Firebase Admin SDK tab, I'll select Generate New Private Key. This downloads a JSON file containing the service account credentials. I'll add this to my project's functions directory. Then, in the index.js file, I need to add that file name to the cloud storage configuration, allowing me to use signed URLs. Now I want to note that anything I put in the functions directory gets sent when I deploy. I added the JSON file containing the service account credentials to my functions directory so that Google Cloud Storage can access them when require is called. Now in part 1 of writing a cloud storage trigger, I used npm to install the Google Cloud Storage module, which looked like this. In order to use the Firebase admin module, I'll need to use npm to install it, just like I did with cloud storage. I'll do that now. Back at the terminal, I'll install the Firebase admin module using npm install save Firebase admin. Now in the last Firecast, many of you pointed out that in npm version 5, save will be the default, so you won't need to include it as I have here. If you're on version 5 or later, you can ignore the part about using save. But since not everyone is using version 5 right now, I'll keep it here in my example. Then, in index.js, I'll require the Firebase admin module. In order to use the admin SDK, I need to call initializeApp, which initializes an instance of the Firebase app. I pass the Firebase config directly to initializeApp to auto-configure the admin node.js SDK with the correct information about my app. I'll store a reference to the root of the database to use later when I add the image URLs. I'm going to need the file object for the original image in order to get the signed URL. I get this object by calling the file method on my storage bucket. This method returns a file object, which contains data about the file, as well as the capability to generate a signed URL that can be used publicly to access the file. I'm going to add a constant called thumbFilePath, which will hold the file path for the thumbnail. You'll recognize the same regular expression from the last Firecast. The getSignedURL method of the file class has one required parameter, config. And config has 2 required attributes, action and expires. Config also has a bunch of optional attributes, but I'll stick with action and expires today. Action is what I want the recipient to be able to do with the URL. In this case, I only want them to view the image, so the action will be read. Expires is the date when the user will lose access to the URL for the designated action. For my purposes, I want to choose a date that is far enough out to ensure the users will be able to access the image as long as the app exists. I'm very confident in the life of my app, so I want to choose a date very far in the future. Oh, and by the way, If you'd like to learn more about signed URLs, as always, check the links below. Alright, now I'll show you how to get the signed URL. Here's where I left off with my cloud function, generateThumbnail. I've already declared thumb file path globally, so I'll remove this declaration. I want to add a reference to the database after the thumbnail image is successfully stored in cloud storage, so I'll use the then method. I'll need the file object for the thumbnail image, just as I needed it for the original image. I use thumb file path here as well. I'll create a constant to hold the values for action and expires to pass as parameters when I call getSignedURL. I'm going to call the getSignedURL method of the thumb file object, which returns a promise that, when fulfilled, contains the URL. I'll call this method on both the original image and the thumbnail, as I want to store both URLs in the database. One call to getSignedURL doesn't depend on the other, so I can call the methods concurrently. I'll return a promise containing an array with two elements, the URL for the original image and the URL for the thumbnail. Once I have an array of promises, I can get the signed URLs and write them to the database. The first promise is from the thumbnail, and the second is from the original image. Each promise returns an array with a signed image URL as the first element. I have both URLs, and I'm ready to add them to the database. The structure of my database is like this. I have a child called posts that contains all of the images users post. Each post has a push ID as a key. This allows me to order by key when I query so that I can show the newest photos at the top of the grid. Then the value of the push ID is two key value pairs, one for the original image and one for the thumbnail. Let's get coding. I defined ref earlier as a reference to the root of the database. I'll create a new reference in the database, child posts, with a push ID created by the method push. I'll set the value of this new reference with key value pairs for the original image's URL and the thumbnail image's URL. Then I'll return the promise. Finally, I'll run Firebase deploy from the terminal to deploy the latest version of my function. Now I can trigger this function by manually adding an image to my cloud storage bucket from the Firebase console, but I have another option that enables me to test my function faster, GSUtil. GSUtil is a Python application from the Google Cloud SDK that lets you access cloud storage from the command line. You can use GSUtil to do a wide range of bucket and object management tasks, including uploading objects. This can cut down on testing time because I can type much faster than I can select an image from a list. Furthermore, I can write a script to upload the images to make it even easier to test. But I'll save that for another day. Want to know more about GSUtil? Check out the links below. Now I'll install the Cloud SDK so I can get a hold of GSUtil. First, I'll check to make sure I have the version of Python that's required to run the Google Cloud SDK. You can check using the link to the documentation, which is provided below. Today, the doc says that I need Python 2.7.9 or later, so I check that on the command line in a moment. You should also verify your version is up to date with what it says in the documentation. While I'm checking the required version of Python, I'll download the software. Now I'll check my version of Python on the command line. Looks good. I'll unpack the file, then run the install script to add the SDK tools. gcloud will make changes to my bash profile to enable me to use shell commands. I'll select yes to allow this. I'll press enter to update the run command file. I'll open a new terminal to let the Cloud SDK commands appear in my shell path. I'll run which gcloud from the command line to show the path where the SDK is installed. Finally, I'll run gcloud init to initialize the SDK. When I run gcloud init, I'll be prompted to log in. I'll do that now, and then return to the terminal. I select my Firebase project as the default. I don't need the gcloud compute component, so I'm going to say no here. And now I'm ready to use GSUtil on the command line. Now that I've installed the Cloud SDK command line tools, I'm ready to upload images using GSUtil. The GSUtil command cp is used to copy files and objects between the local file system and the cloud, copy data within the cloud, or copy data between cloud storage providers. I'm going to use cp with the location of the image I want to upload and my cloud storage bucket to copy the local image to my bucket. Here we go. I'll call GSUtil cp from the command line with my image location and my cloud storage bucket. I get a message confirming that the image was uploaded. I can then check in the Firebase console and confirm that the thumbnail was created. When I click the thumbnail, I can check out its metadata. Then, I can select the Database tab and see that a child was added to the database. It contains the URLs for both images, so I know the function did its work. I now have a Cloud function that's triggered when an image is added to storage. It creates a thumbnail of the image and writes it to storage, and then pushes a database reference containing the URLs to the images. And all this happens outside the client app and works across platforms. You can see just how powerful Cloud functions can be. So did you learn something cool? Want to learn more? Then be sure to subscribe to the Firebase channel on YouTube to get notified about new Firecasts on Cloud functions and other Firebase features. Also, check out the sample code on GitHub to see all sorts of ways to use Cloud functions. The documentation and sample links are in the description below. Thanks for watching, and I'll see you right here on another episode of Firecasts.